Now, the first example we can look at is similar to what we dealt with before. Here we have a picture of a wave that oscillates with respect to position. Right? So it has some displacement from equilibrium, and this displacement from equilibrium changes as you move from one point to another. So given this graph, there's a couple things that you should be able to find. You should be able to find the amplitude of the motion, or the maximum displacement from equilibrium, and then you should be able to find both the wavelength and the wave number of this particular set of motion. Now, to do this, we can do these one at a time. We'll start with the amplitude. So we'll start with this amplitude here. Just like with oscillations, the displacement from equilibrium at its maximum, or the amplitude, does not change here. All you really need to do is from the zero position, or from the equilibrium position, simply find how far at maximum you are away from that. So if you take a look at this red line here, our maximum displacement from equilibrium, which is our amplitude, is simply 10 meters. Right, so for the first one, all we need to do is measure it. Now, for the second one, we're looking for the wavelength of the motion. The wavelength of the motion is almost identical to the period. The only difference is where the period takes the time it takes the wave to repeat itself. The wavelength looks at the distance the wave takes to repeat itself. So you can pick any 2 points on this graph that are the same, and all you need to do is measure the distance that the wave has traveled to get from one identical point to another. And that literally here will measure your wavelength. So if you take these 2 top points, you notice we go from 0 to 20. So our wavelength here is 20 meters. Right, so this wavelength that we have here, we just need to say that it is 20 meters. Now, lastly, we're looking for the wave number. The wave number is a mathematical quantity used to reflect the fact that sine and cosine repeat themselves every 2 pi radians. So our wave number k is always just going to be equal to 2 pi divided by whatever the wavelength is. So 2 pi is a number, so you can just type it in, and then we're going to divide that by the wavelength. And this will immediately yield us k. And if you want to put in the units, it'll be meters to the -1. And that's it for the 3.